hey, just look at the discriminant, just look at the part under the square root there. So what I'd like you to do is very carefully calculate the b squared minus 4ac. One way to look at this, if you haven't done this in a while, is to treat the variables as being in parentheses. And when you substitute, you're substituting in parentheses to avoid potential sign errors. You do this.
Okay.
So go ahead and work that out. Let me know what you come up with. And we'll talk about what that means.
All right. $41.
I got 29. So you got 5 squared minus 4 times 1 times -1.
Oh, for some reason I squared 4. I don't know what I was thinking. It's weird.
All right.
Yeah, 29. Sorry.
Okay, so just to be clear here, this is where this number goes in the quadratic formula. It's the square root of 29. It goes, everything we just did goes into that part under the root there. And we could fill in the other numbers, but we're not going to at the moment. The analysis here is that, okay, I just found my discriminant. Is it positive? Is it 0? Is it negative? And it's positive. Okay, so we know for sure that it has 2 real roots. Like that's the conclusion they want you to draw here. But you can actually go a little bit further. Is the square root of 29, is it nice or is it not nice? Basically, do you know a perfect square root of 29?
No.
No, we do not.
Not nice.
So not nice. So these are irrational solutions.
Mm-hmm.
Now, is that a bad thing? I mean, that's I mean, it's out of scope for what we're doing tonight, but it's like, does it really matter? I mean, I don't know. It's nice when things work out, but in real life, nothing really works out the way we think. So it's actually more common for these to be irrational than rational.
Yeah.
In terms of like, you know, just look at the numbers that you might see. There's more ways to make it not a perfect square root than a perfect square root with the limited numbers you have.
Also, wise words. You know, most things in life don't work out the way we see them to.
They do not. There's a pastor once told me a great formula. He said, expectations minus reality equals disappointment. So don't set yourself up for disappointment by setting your expectations too high.
Yeah.
All right, so that's number 6. So let's go to 7.
Okay. I'm good.
Grab this here.
Us in Arizona, we you know, everybody basically changed their time to an hour earlier.
Yes.
You know, well, we're stuck here, and so it totally ruined my schedule when that happened. It was a mess.
Yeah, it's really bad for that reason. Yeah, I would agree. Do you have a lot of people you communicate with in other time zones? Is that?
Yeah. You know, my girlfriend, she used to live in Germany, so we were both overseas that time, but I moved first, and so yeah, dealt with that for a long while. Yeah, thankfully though, apparently like Congress is going to get rid of daylight savings universally in America next year or something like that. Which, if that is so, I would love that.
I think I've been hearing that for as long as I've been alive.
I know.
There's actually medical reasons to consider the not having it. If you look, there's more medical stuff that happens as a result of time change. You know, people stress out about it, sleep.
Yeah.
There was a guy who went in, he prepared a paper and showed how we could save all this money by not having the time zone shifts or the daylight savings time shifts. I don't know. I don't understand it. I guess if you're in Indiana, I don't know if they still do it. I thought there's maybe one other state that also doesn't adjust.
Yeah.
Anyway.
Hey, it's the cost of living and common sense. You
Now,
know?
did you know that in India they have half time zones?
Really?
Yeah, now that's a weird one because I've had to communicate with people overseas in my life, and they're like, yeah, it's 7, it's like 4:45 a.m. there, and now you're like, what? Like, is your math wrong? I mean, like,
Fascinating.
yeah,
And then, like China has no time zones. Well, just one.
yeah,
So
yeah. Well, China's got they're very special.
indeed,
All right,
one leader,
one
one
time zone.
time zone, etc.
All right, so when you're solving these problems, you have to get everything on one side of the equation. It actually doesn't matter which way you move it.
Mhm.
There could be a preference for like, hey, I really want my leading term to be positive, so let me move it left. It doesn't matter. Like, what way do you see it? Do you see it as moving, so adding 3x to the right, or do you see it as moving these two terms to the left?
Yeah, I'd probably normally move them to the left.
Okay, so that gets you to 2x squared minus 3x plus 5 equals 0. Again, we're going to do b squared minus 4ac. If you wouldn't mind calculating that for us.
Okay. Negative 31.
Yeah. So if we go to the quadratic formula, let me write out more of it this time. So it's minus b minus a minus 3 plus or minus the square root of minus 31 over 2 times 2. Now, if we just look at the part under the root, the fact that the discriminant, we talked about it being positive, being 0, being negative, we're over here in this case. It's the square root of negative 31. This means that there are 2 complex roots, which
Yeah.
implies that you know how to sort of rewrite this, meaning in the real domain, this has no meaning, but in the complex domain, there is meaning to this. The real domain is here, and butted up against it is the complex domain with no overlap. Do you remember how to handle the square root of -1? Like what that means?
31i.
So it's I square
Yeah.
root,
Yeah.
I square
Of
root
31.
31. Yeah. And there's your full answer. But what they're looking for today is just, do you know the path? Which path are you going down for problems like this?
Okay. Gotcha.
So let's look at 27, if you're okay with us moving, because it's kind of related.
Okay. Wait, look. All right. Yeah, sure.
Okay, we're not going to complete the square, or we can, but let's first look at the discriminant by doing the same thing we've been doing.
All right.
So again, you want to move everything to one side. So it's 3x squared plus x plus 2 equals 0. Go ahead and calculate that b squared minus 4ac for this
All right.
problem, please.
Negative 23.
I got negative 23 as well. So again, that tells you that there are 2 complex solutions. Now, also, here's what this means graphically. Does this quadratic open up or down?
Up.
Up. So it looks something like this, meaning it does not cross the x-axis.
Okay.
And that's why maybe this is odd. You're like, wait, it has solutions. Yeah, they're 2 complex solutions, not real solutions. Real solutions would have to cross the x-axis here.
All right.
All right. Now, do you want us to do this by completing the square?
Sure.
Okay. Okay, I'm just going to rewrite it here to start out. I recommend moving the 2 back to the other side. So it's 3x squared plus x equals -2. Now you factor out a 3 from everything. So this is x squared plus x divided by 3, or 1/3 x, leave a space, equals -2 here. Do you remember us doing that? Do you remember us doing that before?
Yeah.
It's a little odd, and it's kind of a tough sell for most students to be like to buy in, but this, because it's really a tough calculation. The 1/3 here you cut in half. That's part of the completing the squares. They call this the b, same b that you used. You cut it in half, and that is 1/6. Okay, that goes down this way by dividing by 2. What goes back is 1/6 squared. So that's 1/36.
Okay.
The number that goes in the red box here, it comes from multiplying in. See how 3 times x squared gets to 3x squared, 3 times 1/3 x gets you to x, 3 times 1/36 is 3/36, or 1/12. And that's what you're going to add in both boxes here.
Okay.
So you do have to add 1/12. So you can think of -2 as -24/12, which when you add it to 1/12 gives you -23/12. Bring the 3 down like that. Almost there. So we're going to divide by 3 before taking the square root. So when you divide by 3, it's like multiplying by 1/3, minus 23/36. Is that okay up to this point?
Yes.
Okay, now when you take a square root on the left, it's fine. It's just like, all right, it's x plus 1/6. No big deal there. But on the right, it's plus or minus, and it's of a negative number, which is consistent with what we said up here, where there was 2 complex solutions, meaning there's an I in the answer. So on the right here, you're taking the square root of the top, the square root of the bottom. On the bottom, it's 6. On the top, it's I square root 23. Just breaking that apart. Make sure that's clear. You're just splitting it top and bottom, because you take the square root of the bottom. Okay, that's good. Keep going here. Almost there. Have to subtract 1/6 from both sides. X equals -1/6 plus or minus I square root 23 over 6.
Yep. Makes sense.
Okay. There was another problem. So 17, I believe, turns into a quadratic. We want to do that and kind of do another discriminant, or if you're tired of doing discriminants, we can move on to something else. Your choice here.
Yeah, sure. 17 and 18 would be 2 questions that I think it would be helpful to have.
Okay.
Yeah. Yep. So we can do those 2, and I think that would be good.
All right. All right, I want to do something just a tiny bit different here. I'm going to graph this. I think, have we talked about Desmos before? Okay. So let me do this real quick, because it's nice to kind of know what's going on before you start. All right. So notice I didn't just graph the thing with an equals. I make the first one like y1, the second one y2. I use x instead of p. When you graph, you're looking for the intersection of the 2 of them.
Okay.
So there's an intersection right there. Now there's a question. There might be a question of like, well, does the blue ever hit the green, or does the green maybe come back? And the answer is no, but you wouldn't know that unless you had a little more math background, some calculus. But you can see, since they're getting further apart, that they continue to get further apart. So we can sort of accept that there's one solution here. All right. Now let's go and actually solve this algebraically the way that they want you to do. All right.
All right.
Any idea how to start this?
So we'd subtract 5 from both sides.
Yeah, I do like doing that. That's the left, the right is this,
Mm-hmm.
and you're going to square both sides.
All right.
So on the right, p minus 35. On the left, if you're not sure, it's always good to rewrite it as two binomials.
Mm-hmm.
That way you don't make the classic mistake of missing a term, because when you FOIL here, you know that you do get square root of p squared or just p. Okay. But you also get other terms, right? You get minus 5 square root p minus 5 square root p plus 25 equals p minus 35, like that.
Mm-hmm.
So actually, I was wrong. This does not turn into a quadratic, but I will make a comment here about something else. So the p's do cancel. They just go away there. You subtract 25 from both sides, and you combine like terms. So it's minus 10 square root p equals minus 60. Divide by negative 10, divide by negative 10. Square root of p equals 6. Square both sides. P equals 36.
Gotcha. All right.
All right. So I think you're owed an explanation, a little bit of an explanation for this. While this works, you can't just square things and like think that that's just gonna work out always. I thought this would lead to a quadratic, and it didn't because these p's canceled out. But when you change something that is, in this case, a root, and you square it so that it's no longer a root, you run the risk of like trying to do things that may only work in one space but not another. And you since you've been in the air, there's probably things that work in the air that don't work on the ground or vice versa.
Mm-hmm.
And that's, you got to be very careful when you square things, because you end up transforming the problem into another order. Like the original order of the problem is square root. When you change the order by squaring it, it's different properties in different orders of the whether it's linear, quadratic, root functions. Not everything applies uniformly there. So a good example of that, and there's this kind of this classic problem you see on Facebook. It'll be something like this, like minus 4, I'm sorry, square root of minus 4 times the square root of minus 9. Okay, there's two ways you will see that this be done. Okay, the correct way is to say, okay, it's I square root 4 times I square root 9.
Mm-hmm.
And then square root of 4 is 2. Square root of 9 is 3. 2 times 3 is 6. I times I is I squared. I squared is negative 1. This becomes negative 6.
All right.
Okay. Does everything look okay? Like, this is correct.
Mm-hmm. Yep.
This is wrong. Following. Square root of negative 4 times negative 9. Square root of 36 is 6. And you might be wondering, why is that wrong? Are you wondering that?
Mm-hmm. Yeah. Yeah, that's why it was originally had.
Okay. This problem can only be done in the complex domain.
All right.
And the rules in the complex domain are not the same as in the real domain.
Okay.
So you cannot apply real domain properties. So what you're trying to do is apply square root of a times the square root of b equals square root of a times b. This is in the real domain. It does not apply to the complex domain.
Sorry, the garage door is opening. I'm in the garage.
No problem. That's story of my life. The big reveal and it gets interrupted.
Yep. Yep, exactly.
It's okay, but I think you're owed this, like, because a lot of times you don't really get an explanation for like, but it's because there's all.
Mhm.
Let me know when you're back.
Yeah, no, I'm
Okay.
here. It's just my sister and dad bringing groceries.
Okay. So is it the idea here is that, like, whenever you make a modification to something, like, it doesn't mean that that every single rule that you've ever learned applies.
All right.
Okay. Um, and there's full courses in math on, like, what to do in the complex domain. Most of your life and as a high school student and somewhat in a college student is in the real domain.
Okay.
So, all right. Where do you want us to go from here? What would be
Mhm.
some problems to look at? You said 18.
Yeah.
Good,
Yeah.
18 next.
Yeah.
Maybe I've asked this. Are you planning to take physics?
No. What we're sort of thinking is next year consumer math, because that's what would be most helpful for aviation, and then I'll be pursuing that path. So
Okay.
yeah.
All right. The two forces are applied to the point as indicated. So that's the point there. Okay.
Mhm.
And they want you to find the resultant force. So the general strategy here is to break apart each force into its x and y components.
All right.
All right, so the one on the right here, let me do it in colors here. So this one, the blue one here is, and we'll just make a big X here. It's 15 in the X direction.
Mhm.
And then there's nothing in the Y.
All right.
The other one is from a triangle, some sort of a triangle here. The angle is
Mhm.
32. How do you find one of the legs of a triangle if you're given an angle and the hypotenuse? Do you remember that? Make sure I can.
You would use cosine.
So cosine will give you the x in this case.
Mhm.
X, or I'm sorry, let me write it this way. The cosine of 32, I know it's kind of not written well. Cosine of 32 is the adjacent over the hypotenuse. So you can solve for x there. It's 12 cosine 32, but it's going to the left. So we make that negative.
Mhm. All right.
This other one is going down. Now you might wonder, why is it going down? It's the idea is it's left and then down to get to this endpoint. There's no other way to get there. You can't sort of go up and then right. You have to start at this point and get there.
Mhm.
So the y value here is sine 32 equals y over 12. So y is 12 sine 32. So the sign, whether it's positive or negative, it doesn't come out of the calculation. It comes out of you understanding the situation.
Okay.
All right, that's why it's negative. That's not the resultant force. That is breaking the forces into their x and y components. You have to calculate these. You got to get numerical values for each of these. So you want to get a value for x and a value for y. And then the resultant is the square root of x squared plus y squared, Pythagorean theorem.
Mhm.
Make sure your calculator is in degrees when you do this calculation.
All right. Good. Sorry, trash cans.
Let me know when
All
you
right.
let me know what you get, let me know when you get some numbers.
Yes. So it's calculating as you're talking. X equals 4.82, and then y equals negative 6.36, rounded, of course.
Okay. Do you do any calculations in the air when you're flying with angles and?
Yeah, although it's mental stuff, so it's not going to be so much with the computer, although you certainly can. We have a flight calculators that we carry around, but for the most part, it's going to be mental
Got it.
once you're in the air, those.
Okay. So the resultant is you take each of those and square them. Make sure you put that negative in parentheses. Go ahead and give me that value.
Okay. All right, 11.7 basically. Around.
Did I not do this right? Go ahead and try that calculation one more time.
Okay.
Did we?
Let's see. Oh, I misread the 9 as a 4. Or sorry, no, sorry, I read the 4 as a 9. Okay, 7.98.
Good. Units of force typically in well, newtons,
Mhm.
but in this problem it doesn't ask you for that. One of the issues with this number is you don't know the direction that it's pointing. You don't know whether it's left, right, up, down, where it is, but it doesn't ask for that. It just asks for the resultant force. It doesn't want you to specify its
Mhm.
direction, although it should, which is kind of odd. But so if it did ask for that, the direction is the arctangent tan inverse of y over x. And that would give you its direction.
All right. So I think, we'd have 7.98 and then just have the angle, and that'd be the resultant force or something.
This is the resultant force, but we don't know which direction
Oh.
it's in. So I think that's why I mean, it didn't ask for this, but usually you give both the magnitude and direction.
Yeah, I think that's what she's requiring.
Okay, so let's calculate that here. The arctangent of y over x.
Okay.
And so I get minus 52 degrees, 52.8 degrees.
Mhm.
Let me know if you get something similar.
Okay.
Are you in agreement with this number?
Let's see. Where are the X my values again?
Let me scroll up here.
All right, there we go. All right. Okay, yep, I got the same.
Okay. So the like what I would want is more than just the r and the angle. I want you to actually draw the resultant vector and show me the angle here so that we know like where it's going.
Mhm.
Like imagine, in physics it's sort of this like collision, and it's like where did what ends up happening? Well, you end up going out that way.
All right.
All right. So we usually do a problem on like r and theta. That might have taken care of that type of problem for
Yep.
today. What else do you want to work on? I do see like a system that might be worth working on depending on
Mhm.
what you want to do. It doesn't matter to me. You're the customer, you dictate here.
Yeah, sure. We can do that.
All
Yeah,
right.
we got most of the very difficult ones. Oh, for me, anyways. I'll throw it through.
All right. Okay. Got a system here, 3 variables, 3 unknowns. Anything jump out at you like when you look at it, when you're inspecting this? Anything you kind of see that might guide you about what to do?
Um, I would probably use the last two. Um, and then subtract the y and the z to get 5x equals 20, which means x equals 4.
Yes. So what I heard here is that when you add them together, because they're opposite in sign, the y and the y's cancel and the z's cancel, and you can quickly solve for x. So x ends up being 4. Okay, that's good. But that only gets us part of the way home, right?
Mhm.
It effectively eliminates x in all of these equations. Okay, so it might be worth rewriting them. You can actually make a quicker sort of way of doing this. You can treat it as minus x over here on the right, minus 2x, minus 3x, and that might speed up the calculation. So it'd be like y minus 2z equals -7, y
Mhm.
plus z equals -1, and then minus y minus z equals +1.
All right.
So this is great. You got one of your three unknowns.
Yeah.
You cannot combine the second and third again. You've already done that, so you can't do that, which means you've got to combine.
Mhm. So then I'd probably use the first equation, y minus 2z equals -7, and I would turn that to y equals 2z minus 7, and then substitute that.
Okay, so that will work here. I heard y equals 2z minus 7, and you want to put that into that equation.
Yeah.
Okay, why don't you do that and solve that for us for z.
Okay. Z equals 2.
Z equals 2. Okay, and then can you find the value of y?
Yes. Y equals -3.
Okay, how can you ensure that your answer is correct? Let's just say this was a test,
By putting the three numbers into any of the equations and then seeing if the left and right hand side equal each other.
No, I'm gonna be kind of legalistic here. You said any of them. So if I try it in one equation and it works, do I know that it works in the other two?
Yes, because this
How
is
do,
a system.
so that's very dangerous. It has to work in all three. All
So
three.
put it in all three then.
Yes.
All right.
Which is a lot of work if you had to do that, which is
Yeah.
why you really want to make sure you're solving it is correct.
Yeah,
Um,
exactly. All right. Let's see. Okay, I guess for the next question, we can do question number 11.
okay, sounds good.
And then if we have time, probably just one more after that, which would be 8 or so, but we'll go and do 11.
All right, number 11. Can you tell me what geometric shape this first one is a graph of?
Circle.
Circle, yeah. And a circle could be hit by a line, could be missed by a line, could hit it in two places, right?
Sorry, my sister was just talking to me. Go ahead.
She's answering the question for you.
Yep.
All right. This is important. You want to know like your target. But we in math, they talked early on about like drawing a picture. Like this is why you draw a picture. You want to know like what's possible. Like I'm either going to get one solution, two solutions, or no solutions. Okay. These problems are always solved by substitution.
Yeah.
So we're going to solve that second equation for x. X is 2 plus 2y. That's going to go into this one right here. 2 plus 2y squared plus y squared equals 1.
All right.
You're going to want to expand this binomial. So it ends up being 4 plus 8y plus 4y squared plus y squared equals 1.
Okay.
So we combine like terms here. 5y squared, subtract 1, plus 8y minus 3 plus 3 equals 0.
All right.
And boy, awful. You got to use the quadratic formula on this. So let's do the whole discriminant thing again. I want you to calculate the discriminant for me. B squared minus 4ac
All right. Four.
Or
For D.
really works out nicely. Sure does.
Nice.
Okay, so I was jumping at here. We do not have used the quadratic formula for this.
All right.
The reason is this becomes 4, like you just said, and 4 is a perfect square. So
Mhm.
the all, do you remember like first time you learned factoring, it was like x squared minus 6x minus 7, this type of factoring?
Yeah.
The discriminant on this is always a perfect square root.
All right.
So that's how I know that this would have factored nicely. The factoring here requires you to take 5 and 3, multiply them together. That's 15. And then you're looking for two numbers that multiply to 15 but add to 8. So it ends up being 3 and 5, which is nice.
Mm.
So this is 5y squared plus 5y plus 3y plus 3 equals 0. And then we haven't done this before, but this is grouping. You factor out a 5y from both, so it becomes y plus 1, y plus 1 equals 0. You can factor out a 3 from that other one. So this ends up being 5y plus 3 times y plus 1. You might have seen this a different way.
Yeah.
You can use a guess and check approach, but they typically teach it with this grouping now. But you get your two values of y. Y is either -1 or y is -3/5 because you're setting them both equal to 0.
All right. And I suppose that they could also be y equals 1 and 3/5.
No, you're setting them
Okay.
each equal to 0. So you're
All
setting
right.
5y plus 3 equal to 0, y plus 1 equal to 0.
Okay. All right. I see.
Now, sometimes you get so deep into a problem here, you forget like, what are we actually trying to do? And we're trying to solve for both x and y.
Mhm.
So we go back, it's like, oh yeah, like we're solving this thing. And we know that there could be two solutions. In this case, there are two solutions, but those are only half of it. Like each of these are ordered pairs.
Okay.
So your x value is 2 plus 2y. So you have to use each of these in that equation to find x. 2 plus 2 times -3/5, which is -6/5. 2 is really 10/5. So that's 4/5 for your x.
Okay.
So that's an ordered pair, -3/5, 4/5. Same thing on the right here, x equals 2 plus 2 times -1. X equals 0.
All right. Well. Okay.
So it worked out nicely, thank goodness, on the one
Yeah.
on the right.
Let's see.
All right, so you said maybe another question. We'll see if we can quickly run through some of
Yeah.
it.
Just question number 8, I think.
All right. Okay, let's look at the one of the bottoms here. Here is easier to graph.
Mhm.
Y greater than or equal to 1, -1. So here's -1. And it's shading everything above. Now I don't shade yet. I just sort of draw these arrows to indicate that we're going to
Mhm.
go that direction.
All right.
The other one, you're going to use the intercept approach to graph it. So when x is 0, imagine covering up the 0, y is 1. That's there. And then
Okay.
go the other direction. Well, if y is 0, then x is 2. If you cover up what 2 times 0 is 0, x is really 2.
Mhm.
This one though is a dashed line because that symbol there. So that's enough to get this. To decide whether you shade above or below it, you test a point. So we're going to test 0, 0, because it's nice point. It's right there. Is 0 plus 2 times 0 less than 2? Yes, it is. 0 is less than 2. So that's the true side. So you draw these arrows, and what you're looking for is where are these both true? Where are these both true? And it's in this
Yeah.
triangular region here. So notice you don't graph until the end, because you'll
Right.
inevitably make it look wrong.
Yeah. Make it look
there.
miserable.
Yeah. All right. Well, unfortunately, we are out of time. Always enjoy it. Great helping you.